Okay, you all. So, yeah, this is weird, right? But we just gotta work with what we have here. Okay, this is weird. I'm doing a video in my classroom without you all here, and I'm so sad. But here's the thing. We have to get rolling on this assignment. What we're gonna do, so you should have out your assignment in front of you. Okay, please go ahead and either print that, or you should be looking at it on your screen and then like writing down on your own piece of paper the problems, and go ahead and write down everything that I'm doing just like you would in normal instruction. Okay, that's going to be really important to be successful the next 2 weeks. Okay, so here's what we're going to do. We're going to look at this paper on your computer or on your actual paper at numbers 2 and 3 right now. So what we need to be thinking about is when we use elimination and when we use substitution. Okay, those are going to be the things that we need to be thinking about right now, because on the test, I'm not going to say, hey, solve this system by elimination, or hey, solve this system by substitution. I'm not going to do that. You're going to have to know which one to choose, okay, and that's going to be important. So I want you to look on number 2 and number 3, and I just want you to think to yourself, all right, and I'm going to give you time to do that, and I know it's going to be weird, but I'm going to give you time to do that. On number 2, would you use elimination or substitution and why? Okay. And then on number 3, would you use elimination or substitution and why? So go ahead and think about that to yourself for about like 30 seconds. I'm going to step out of the view. Okay, let's you look at this. Okay, so we're actually going to talk about number 3 first. I know that's weird, but that's what we're going to do. Let's just think about number 3. So I'm hoping, and obviously I would, if you were here, I'd let you share out and we'd have a conversation, but we can't do that. So when we look at number 3, now I'm hoping that you would not try to do elimination with this. Okay, I'm hoping, we're going to talk about that in a minute on why, but I'm hoping that you all were like, okay, I'm going to use substitution. Now, here's the thing. On substitution, we know that we always want a y equals blah, 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 right? Or an x equals blah, 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 blah. Now, if it's y equals blah, 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 that means it's in y equals mx plus b form. But the bottom line is we have to know what x or y equals. So if you want to look at number 3 here, if we circle this bottom equation, which I'm hoping that you already did that, but if you didn't, that's okay. We have something that does say x equals an equation, okay? And that's great. So the bottom line here is that, and I'm going to kind of write this down here if I can. I'm like this is kind of, I hate writing on whiteboards, by the way, because I'm left-handed, but we want to use substitution. I'm going to abbreviate this. Okay, there's 2 kind of things here. One, so go ahead and write this down, please. When we have x equals blah, 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 all right, which we have in number 3. We know what x equals, so we might as well substitute it in, right? Or number 2, when we have what? So it's going to be similar to number 1. Okay, so think about that for a minute. But when we have y equals blah, 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 blah. So those are the 2 circumstances that we want to use substitution, all right? So let's go ahead and try to solve this by substitution, knowing what we know. We are going to substitute this in for x. Now, why wouldn't you put it in for y? Think about that for a minute, because that's kind of what we're used to, but this is a little bit different, all right? We would put it in for x because this equation is what x equals, so let's put it in for x, not y, all right? I'm hoping we're following here. So let's go ahead and do that. So we have 1 equals -2. Put your equation in for x, all right? Now I realize I'm left-handed. We can't really see what's going on, but just try your best. So we should have that. 1 equals -2. Put that x in, 2y plus 2 plus 9y. Now what we want to do, as you all know, we want to go ahead and distribute, all right? And you all know that. Go ahead and distribute. Okay, bam, bam. We should have 1 equals, what, -2 times +2, -4y. All right, -4 plus 9y. Now this looks a little bit different than what we're used to, but breathe, follow your steps. We've distributed. The next thing we need to do is combine like terms, right? Don't call me after midnight. That's C. We got to combine like terms. I'm going to have to move over here, guys. I'm sorry. Y'all know my handwriting is huge. So combine like terms. That's going to be your -4y and your +9y. Okay, let's move over here. I hope we're following here. So we're going to have 1 equals -4y plus 9y. Okay, just knocked over the garbage can here. That's going to be 5y positive. 5y positive. Okay, so we're going to have 1 equals 5y. We still have that -4 there. All right. Now we have a beautiful, and I'm going to draw an arrow here. We have a beautiful 2-step equation. Yeah, just beautiful. So we're solving for y. So as you all know, we're going to add 4. I'm just going to do this very quickly. So we have 5 equals 5y. Then we divide, and we should have y equals 1. Star that number. Okay, I'm going to give you a minute to write that down. Okay, y equals 1. Well, now the question is, well, how do we get x? All right, remember, we have a y, we need an x. We need an x and a y when we do these system of equations, which is not too bad. Remember, we're going to substitute this y in for the equation that we circled. That makes it really easy for us, okay? Y'all are doing great here, and I know you are. So we're going to have x equals, oh, that's kind of a weird green here, but that's okay. X equals 2, put in that y times 1 plus 2, okay? And we should know that x equals 4. Star that number. We have one last step. I'm going to go ahead and give you a couple seconds. All right, we have one last step, and as you all know, we need to put these in a what? I can hear you all saying it from home. An ordered pair, please. So we can do like this. Remember, it's x comma y. So we have 4 comma 1 circle check mark. Okay. Now, if you have any questions about that, please go ahead and ask me, through Remind or my email or on Google Classroom. Now, remember, the directions that I put for this assignment is that you have to do all the work. Okay, that's 1. And 2, you have to tell me what method you're using. Okay, so here we use substitution and why you're using substitution. So for example, on this one, worked out problem, here's my ordered pair circled and check mark. I use substitution because we have x equals an equation, so we know what x equals and we can go ahead and substitute that in. Okay, that'd be a perfect explanation there. So I'm gonna go ahead and give you a few seconds to kind of gather your thoughts around that. And yes, I am sick, but I don't have corona though, so that's great. Okay. So that's number 3. We're gonna talk about number 2, which I think is more obvious, I think. Let me just go ahead and make sure it's still recording here. Yeah, great. Number 2, I think it's a little bit more obvious on what you would do, but I don't think it's as easy to explain why. Okay, let's talk about that. So we have what number 2 looks like. I'm hoping that you all would have picked elimination here. I'm hoping. So let's go ahead and put like our elimination, like we did substitution down here. We're gonna go ahead and put elimination. All right, and I am gonna abbreviate that as just elim, whatever. So let's talk about when we wanna use elimination. Like I said, I'm hoping that you all kind of notice that. You're like, oh, I would use elimination for that because it doesn't just looks weird to use substitution. But let's talk about why. It's kind of hard to put into words, but, so let's just put number 1. We use elimination, this is gonna be like, you're gonna be like, really, Michelle? Like, I could have told you that. We use elimination when we don't have x equals something or y equals something. Okay, clearly. But that's when you use elimination. So go ahead and write that down. And I know I'm left-handed, you can't see what I'm doing, and I'm so sorry. But when we don't have x equals something or y equals something, okay? That's number one. We use elimination when we don't have x equals something or y equals something. Now, it's a little bit more deep than that, though, because we're going to talk about things tomorrow that aren't in x equals something or y equals something, but we still might not want to use elimination. So it goes a little bit deeper than that, okay, you all? So I'm going to say the second thing, and I'm sorry, this is so dumb, but I'm going to have to write it up here because I'm running out of room on the board. So number two, we want to use elimination when, okay, let's back up. Substitution is more or less left to right. And we talked about that. Substitution is more like left to right. And we talked about elimination is more or less what direction. So go ahead and think about that. More or less what direction? So I'm hoping that you all are thinking up and down, right? It's more of an up and down process. So thinking about that, let's just look up and down this equation. Up and down this equation, we have the x's lined up and down. Great. We have the y's lined up and down. And we also have the regular numbers lined up and down. So that's why it goes a little bit deeper than that, you all. We want to use elimination when the variables, so I'm sorry, I'm going to have to switch sides. The variables and numbers are lined up. So, are lined up. So, meaning up and down, we have the x's in a column, the y's in a column, and the regular numbers in a column. So, when the variables and numbers are lined up. Okay, so yes, number one, when we don't have x equals something or y equals something, but even deeper than that, we want to use elimination when the variables and numbers are lined up already for us. Okay? So go ahead and take a couple seconds to write that down. Okay, so let's go ahead and talk about how we would do this elimination problem. Okay, so clearly not one of the variables eliminates right now. So we have to make it eliminate. So I need you to think about what operation we need to do. Do we need to add? Do we need to divide? Do we need to multiply? Or do we need to subtract? So think about that. All right. I'm hoping that we all know that we need to multiply to make something eliminate. Now, okay. I need you to think about if we can even make the x's eliminate. Is there anything we can multiply 6 by to get to 10? Okay, no. So that's not going to happen. So we need to get the y's to eliminate. So to get something to eliminate, remember you have to have the negative version of that thing and the positive version of that thing. Not both negatives, not both positives. You have to have the positive version and the negative version. Well, if we look at the y's, we know that we need to multiply the top one because this bottom one is bigger. Remember that we always multiply the one with the smaller numbers. All right, now let's think even deeper than that. We already have a negative 6y here. What do we need on the top? So we have a negative 6y. We need something on the top to get that to eliminate. Okay, think about that. Okay, well, we need a positive 6y, okay? So how could we get, remember this is like a 1 in front of here, if you want to write that. How do we get 1y to be positive 6y? How can we get 1 to be 6 through multiplication? Multiply by what? So think about that. I'm hoping that you're saying 6. All right, we need to multiply by 6. That being said, remember that we can't just multiply one thing. We have to multiply all of it. So do that, do that, do that, all right? So let's just go ahead and figure out our new equation. So my new equation, okay, 6 times 6x, that's 36x. Okay, 36x plus 6y equals 54. Okay, my marker's running out here. Pushing my luck with my markers. Let me go ahead and try to write over that, I guess. So 36x plus 6y equals 54. Now remember, this top equation is irrelevant. So these are your two equations that we are working with here. So you would solve this system of equations. The y's eliminate. Then you need to add or subtract down. Okay, that's what we have trouble with, and that's okay. But this is a negative 10 plus 36x. Okay, not minus 36x, because this 36 is positive, so we add. So it's going to be negative 10 plus 36. And then on this side, it's going to be negative 2 plus 54. Now, let's just say, it's not, but let's just say that this 54 was negative. Let's just say. If this 54 was negative, we would do negative 2 minus 54. But since it's positive, that's why we add. So you would add or subtract down. In this case, it's add. Solve for x. Plug x back into this equation that you didn't multiply and solve for y. All right? So remember that on this assignment, you're going to do all the work, have an ordered pair circled and check marked. That's 1. And then 2, what method you used, and then an explanation of why. So like on this one, I would have all the work and ordered pair circle and check mark, and then I would say, hey, I used elimination because the variables were already lined up for me. Okay, so it looked easier to do elimination. The variables were already lined up, and I didn't have x equals something or y equals something, so I didn't use substitution. Okay, I used elimination. That's why. Okay. If there are any questions, please, 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 I'm begging you all. I'm available. I'm trying to be as helpful as possible during this. This is not ideal for anyone. I wish we were here. But if you need help, remember, remind, email, or on Google Classroom, okay? So please ask me questions if you are confused.